So every exam paper or paper one exam paper there's been in this new spec, and it's not even new anymore now, actually, is it? Because it started being taught in 2015. But every paper one has had a mass spectrometry calculation question, and so they are never going to be a surprise. You basically have to assume they're going to happen. They're going to be up to 5, maybe 6 marks. And what you definitely don't want to do is not get those marks. And thinking about this particular question, so if we read what it says, in the time of flight mass spectrometer, an ion has a kinetic energy and then gives the value. This ion takes and gives us the time to travel down 0.857 meters down a flight tube. Then it asks us to calculate the mass number of this ion. Okay, that's fundamentally what this question is asking us to do. Now, something to really point out is this is singular. All right, it's a single ion. Now, what that means is that our final mass number has got to be an integer. We're not talking about a mole of them. We're not talking about, well, even if we were talking about a mole of them, actually, but we're not talking about a variety of isotopes, okay? We're not talking about an average of the isotopes. We're talking about a single ion. So this will have to be an integer. That means a whole number. Okay, so they've very kindly given us a rearranged equation. So they've rearranged the kinetic energy equation so that it's in the form of V. However, we are essentially working out the mass. So we're going to have to change that equation, rearrange it so that M is the subject. Now, I'm not even going to think about any numbers until I have got that equation rearranged so that it is with M in the subject. So I've already rewritten what they've given us, because that's what I'm going to manipulate. So the first thing I'm going to do is I'm going to square everything, because I want to remove that square root sign. Okay, so we're going to have V squared equals 2ke over M. And then I will need M to be the subject. So what I'm going to do is I'm going to multiply both sides by M and then divide both sides by V squared. So in effect, what I am doing is I am swapping these two terms. So what I get is M equals 2ke over V squared. So if I look at the data I've been given, I have been given, if I look, there's the kinetic energy, I have been given the kinetic energy, but I haven't actually been given the velocity. What I have been given is time and distance. And so one of the things then that you have to recognize is, and you need to remember this, is we've got a calculation to do before we put any numbers in, and that's to work out the velocity, which is distance over time. Now, if you weren't feeling 100% sure that it was distance over time, then what you do, or what you should do, is look at the units. So that is saying meters per second, and that is our dividing. That's our good grief, what is that called? But anyway, my mind's gone blank. But we are saying we have got meters divided by seconds. We have got distance divided by time. So if you're not 100% secure on knowing that velocity is distance over time, look at the units. Or look, if you're not 100% sure of a formula, then look at the units, because often they give you the information. So that allows us to work out velocity. So our distance is 0.857, and it was meters, and then divided by our time, which is in seconds, which is 1.28 times 10 to the minus 5, and that gives us a value. So 0.857 divided by 1.28 times 10 to the minus 5. Okay, so I'm going to write out up to the decimal place. Now the thing is, that is in my calculator, all right? Because I'm just going to leave it like that now. So now I come back to my rearranged equation. So I'm going to write out what that sum actually is. It's going to be 2 times, and then the kinetic energy that it gave us at the top, which is 2.01 times 10 to the minus 16 times 2.01 times 10 to the minus 16. I'll just put brackets around it to make it clearer. And then over, and then it's going to be this 66953 squared. Now, the reason for doing all the rearrangement first before, well, there's lots of reasons actually. You're much less likely to make a mistake. But one of the things that I think now makes life a lot easier is this is literally what I'm going to put one sum now into my calculator. And I don't have to start then manipulating loads of numbers. Because the last calculation I did was to work out this velocity, what I'm going to be able to do in my calculator here, when I do this fraction on my calculator, and I'm literally going to do it as a fraction. All right, I'm going to use the fraction button, but this is going to be answer because it will be the answer from the previous one, which is this. So I'm going to rewrite. I'm just going to press the answer button, and then I'm going to square it. So let's do that calculation. So I'm pressing my fraction sign. I'm now doing 2 times. I'm going to put the brackets just to be safe, but I don't actually need to, I don't think, but I'm just going to do that because that's how I've written it out on my calculation there. And then over, divided by, and then I'm pressing answer, and then I'm pressing squared, and then I'm pressing my equal sign, and I get 8.96. or an 8.97, I'll round it at that point, but I'm just leaving it in my calculator, so it's only how I'm writing it out, times 10 to the minus 26. So that is the mass of my ion, okay? That's the mass of my ion. Now, if I want the mass number is based on having a mole. So I'm now going to, so I'm going to put now, so this is of a single ion. So the mass of the mole of ions equals my 8.97 times 10 to the minus 26. Oh, and sorry, I've something ahead. We've got to remember, right, when we're talking about this kinetic energy equation, mass is in kilograms. So I've got 8.97 times 10 to the 26 kilograms. Let's just move that across to give myself a bit more space. Sorry about that. And then times by Avogadro's number. So if they give you a number in a question, which they've done here, you are going to have to use it. If you find that you haven't used it, they're almost prompting you, actually, they're giving you a clue by giving, well, I mean, obviously they've got to give you the number for you to be able to answer the question, but they are giving you a clue by doing that. They're telling you that you're going to have to turn something into a mole at some point. So the answer to that is, so I've just left everything in my calculator, so now I'm just doing times, so it comes up answer times, and then 6.02 times 10 to the 23. Okay, so that equals 0.05399, but it's kilograms. And we know that in chemistry, we work in grams. So I'm going to multiply that by 1,000. So I'm just going to do it on my calculator times 1,000. So that equals 53.98 grams. And now when it comes to the mass number is based on a mole, or you know the way that you think of it, you do AR or MR, and it's the relative atomic masses added together. but we know that this is a single ion, or this is one isotope, or we're doing the mass number of this single ion, sorry. So we've got to have an integer, and we round to the nearest whole number, and that is 54. So if we sort of only got to this point, we would have got 4 marks. So the 5th mark was doing the final mass number and having it as an actual integer, as a whole number. So I hope that was all made sense.